All right, this is the third recording for the week after taking your first test. And now I want to present you with a slightly new situation. And this new situation is another type of t-test situation, but it's kind of unique. And the example I want to focus on here is an example that's very near and dear to my heart because I think it's a good teaching example. It's an example using 3 people who have asthma. Now, as many of you know, I run an asthma self-management or education program, and the goal of my program is to take people who have asthma and see if after my program they're actually doing a lot better. So if you read the problem, I take a group of 3 people with asthma. I design a program, educational self-management, to improve. A typical thing is quality of life. Now, the key is to see if they're actually better. So what I actually do is I measure them before the program actually starts, and I measure them after the program is done. And the idea is, does the program actually work to improve their quality of life? Now take a look at the data set there with A. So with A, how many people do I have? You can see I have 3 people. Look what happens to the 3 people. One person starts with a very low quality of life. They start with a 1. They move up to a 5. The second person starts with a quality of life that's a little bit better. It starts with a 4 and it goes up to a 9. And the third person starts with a 7 and moves up to a 13. Now, just eyeballing that data set, does it look like my program is being effective? Most people would argue the answer is yes. But the statistic for this is going to be a little bit different. The statistic for this, and there are a few different names that Chapter 11 calls it, it's called in the most general way a repeated measures design. Repeated measures, related samples, or within subject design are the 3 names for this. Repeated measures, related samples, or a within subject design. And it's a very unique case because in the previous chapter, the idea is people were only tested one time. And when you're testing people just one time, that's called an independent measures. In this situation, it's called a repeated measures because you're taking people and measuring them twice. And so what we really care about is how people change when they get the intervention. It's a little more of a sensitive type of design because in this case, it doesn't matter what the group means are so much, but what really matters is how much did people change when they got my program, because you're measuring them 2 times. So if you go down to the SPSS printout in that table right below it, we have typically in a paired sample t-test, typically we have the pre-test results, the mean is 4, the post-test results 9, get the means. N is 3 and 3. You can measure, if you wanted to, sums of squares, sample variance, and sample standard deviation. It's 3 and 4, and then the standard error of the mean, in this case, just from the individual ones, 1.7 and 2.3, measure of dispersion. If we go to the other page, the second page, we actually have a slightly different printout here. Let's see if we can actually figure this out. So notice it doesn't have the same information as the previous one, but basically what you need from this is a numerator and denominator. And so the idea is, can you see in that paired difference table what the denominator is? It's 0.577. So you want that number to be small. The treatment effect. What is the treatment effect? Well, the treatment effect is simply the difference between the 4 and the 9. So the numerator would be a 5. And if you put a 5 over a 0.577, then you get the t-score. So see if you can compute that yourselves. I should have done it myself, but I did not. And then if you go over to the next line, you get 2 degrees of freedom. Can anybody figure out how you get 2 degrees of freedom? Well, you have 3 people, so it's n minus 1, so it's 2. And then most importantly, look at that sig column. Sig 0.01. Is that good news for us? Yes, indeed it is. That tells you the probability of getting this result will happen due to chance one time out of 100. This is statistically significant. You would simply write out the t-score. T with 2 degrees of freedom equals whatever your t-score was, and then you write p equals 0.01. So in this particular situation, it looks like the t-score, the program is being successful. The big thing that I want to emphasize about the difference with the t-test is, if you remember the general t-score formula, the numerator is the treatment effect. The denominator is some sort of measure of error. And what's really important here is what happens to the error in this case. What's really, really good about the t-test is the fact that you're basically measuring people, comparing them to themselves. Look at those 3 people again. Person 1 started out with a 1, person 2 a 4, person 3 a 7. What's really important is not where they start, but what's really important is how they change with the treatment. The person 1 goes from a 1 to a 5, person 2 4 to 9, person 3 a 7 to a 13. The great thing about the t-test for repeated measures is that the denominator removes out from the error individual differences. The denominator removes from the error term the individual differences, the starting point for these three people. So when you do a paired sample t-test, this related sample t-test, did I give it another name, paired sample t-test? The good news is the fact that each one of these 3 people start at a different point, that would usually make a lot of error or a lot of noise in the denominator, but in this case it's removed from the denominator. The individual differences are taken out of the denominator, so that makes the denominator, the error, much smaller. It doesn't matter that person 1 started with a 1 and person 3 started with a 7. What matters in a paired t-test, because you're measuring every person twice, is that what does the treatment actually do? So hopefully you understand the paired sample t-test, you understand the difference from the independent sample t-test. What I'm going to ask that you do here is basically the homework problem B here, where you fill in the information, see if you can write things out. Don't worry about the confidence interval thing here. I won't explain that at this point in time. We'll explain that, come in next week with the information at hand. If you notice with the paired sample t-test for your homework, you get the mean before, you get the mean after. It has a lot of the numbers there. See if you can figure out if it's statistically significant in the real world conclusion. For my homework problem, you can probably figure out that my program does have a good outcome, that the asthma program, even with 3 people, work. And the big advantage of a paired sample t-test is that you remove individual differences from the denominator, so you get a much smaller error in the standard error of the mean. So good luck. Thank you. Send me drafts through Saturday or Sunday.